Okay, for what we have in section 8.1, okay, we're looking at solving for systems of equations. And now we have with our equations, okay, we have 5x plus 3y is equal to 17. And we also have x is equal to 3y minus 11. Now we're looking at the values of x and y that will fit into both equations. Now I have x expressed in terms of y. So what I can do here is that for this system of equations, I can take 3y minus 11 and plug into x for the other equation. So in this situation, I can substitute for x. And then solve for y. And upon doing so for 5 times x, I can write this as 5 times the quantity of 3y minus 11. And I have followed by the addition of 3y is equal to 17. And we have with the distribution 5 over the quantity of 3y minus 11. This would be 15y minus 55 plus 3y is equal to 17. And we have combining the y terms, 15y plus 3y will make 18y. I have minus 55 is equal to 17. And isolating the y term, if I add 55 to both ends, we're going to have that 18y is equal to 17 plus 55, which will be 72. And guess what? We have with 18y equal to 72. We have with division by 18. Okay, so we have y is equal to 4. And I can plug in the solution back into y for either equation. And I'll just take the first. So you have with x equal to 3y minus 11. So I have y equal to 4. And we have in the follow through. So we have x is equal to 3 times 4 minus 11. And 3 times 4 is 12 minus 11. So we're going to have that x is equal to 1 and y is equal to 4. And so you can always check if x is at 1 and y is at 4. Yeah, 1 is equal to 3 times 4, which is 12 minus 11, which is 1. 1 is equal to 1. And for x at 1 and y at 4, 5 times 1 is 5. 3 times 4 is 12. And 5 plus 12 is equal to 17. So we have in the solution, we have x is equal to 1. And we have y is equal to 4. And you can also write this as an ordered paired solution, again, in the xy coordinates, whereupon we have xy is equal to 1, 4. Now, we have with the second item, and we have 2x plus 5y is equal to negative 23. And we have our second equation, we have isolated the variable x, whereupon we have this set equal to 2y plus 11. And we can take what we have, again, for the expression upon which we have x to be isolated. We can substitute for x in the first equation and solve for y. So again, a bit of history repeating itself. So again, you have substituting for x, solving for y. So you have with 2 times x. Okay, so you have 2 times the quantity of 2y plus 11 and we have plus 5y, okay, is equal to negative 23. And we have a distribution, 2 over 2y plus 11. That would be 4y plus 22. And we have plus 5y is equal to negative 23. And we have 4y plus 5y becomes 9y plus 22 is equal to negative 23. And isolating what we have in y, and we have upon taking 22 away from both sides, so we have 9y is equal to negative 45, and we have with division by 9 into negative 45 becomes negative 5. And with y at negative 5, I can plug a negative 5 into y for either equation and solve for x. And since the second equation already has x by itself, so we have, and plugging in, okay, so we have for x, we have 2 times negative 5 plus 11. 2 times negative 5 is negative 10 plus 11, and so that is equal to 1. So you have x at 1, y at negative 5. So we have 2 times negative 5 is negative 10 plus 11 is 1, which we have for x. Also we have 2 times 1 is 2. 5 times negative 5 is negative 25, and 2 plus negative 25 is equal to negative 23. So you have x equal to 1, and we have y equal to negative 5. So I was able to solve for 1 and 2 by substituting. Now, for what we have in the case of number 3, we have a system of equations whereupon we have 3x minus 8y is equal to 3, and also where we have negative 3x plus 13y is equal to negative 18. And what I can do here, okay, I already have additive inverses between the x terms, so I can utilize what is referred to as the addition method. And if I add the equations together, okay, so we have 3x and negative 3x will go out. And we have negative 8y plus 13y, that will be a 5y. 3 and negative 18 will become negative 15. And with 5y equal to negative 15, we have y is equal to negative 3. And if I look at solving for y, again, I can, after y equals negative 3, and solve for x. So I can take negative 3 into either of these two equations. So with y at negative 3, so if I plug in negative 3 for y in the first equation, so I'm going to have 3x minus 8 times negative 3 is equal to 3. Here we're going to have 3x plus 24 is equal to 3. And taking away 24 from both sides, so we're going to have 3x equal to negative 21, and we have with division by 3, we have x is equal to minus 7. So we have x at negative 7 and y at negative 3, and I can always check the results. You have 3 times negative 7 is negative 21. Negative 8 times negative 3 is going to be a positive 24. Negative 21 plus 24 is equal to 3. Likewise, we have for the other equation, negative 3 times negative 7 is going to be a positive 21, and 13 times negative 3 is a negative 39, positive 21, and a negative 39, if you add together, will come out to negative 18. So we have, for the solution, we have x equal to negative 7, y equal to negative 3, and you can also express this, once again, in ordered paired terms. We have negative 7 and negative 3.